Thanks to everyone for joining the webinar today. So this is a Spire's webinar focused on exploring AIS for federal government customers. And a special thank you to our partners at Esri and Applied Ocean Sciences for supporting us on the webinar here today. So my name is Janie Arechko, and I'm the Product Marketing Manager for our federal team here at Spire Global. And I'm joined today by John Fry, who is a Senior Solution Engineer at Esri, Chris Verlinden, who's the CTO of Applied Ocean Sciences, and my colleague, Max Abushar, who's an AIS and Weather Sales Engineer here at Spire Global. So we're all really excited to talk to you today about the different ways you can use Spire's AIS data coupled with Esri's data visualization tools to address different types of government use cases. And I want to thank everyone for the feedback that you gave when you signed up for the webinar, because it looks like most folks are fairly familiar with AIS data, have a basic understanding, which is great. So we can keep our focus on our newest features and the different ways to visualize the data. So that's awesome. And it also looks like a lot of people who signed up are already ArcGIS users or familiar with Esri. But if you're not, and you seem interested in the service, definitely when we're done with the webinar, feel free to reach out to John or myself, and we can kind of help get you set up with that. And so just as everyone kind of settles in, I know a few more people are joining as we're going on here. Please feel free to use the question and answer feature that's in your GoToWebinar. You can use that throughout, and we can respond to those questions when we get to the Q&A portion at the end. And in addition, something to note, at this point, everyone else is automatically on mute, so no need to worry about muting yourself or any background noise. So here's the content that we're going to cover today, and you'll hear from all four of us that I mentioned on the previous slide as we go through this. So I'll start by giving a quick overview of Spire Global at a company level, and then my colleague Max will dive into a little bit of a deeper explanation about our AIS data and different US government customers that we are working with to fulfill their requirements. And then I'll hand things over to John, who will talk about the various ways you can visualize Spire data within Esri ArcGIS and do a few demos and show the Spire data and ops dashboard. And then we'll kick it over to Chris from Applied Ocean Sciences, who will discuss how Spire data can be integrated into a customer workflow. And he'll focus on his work with ocean ambient noise modeling, along with a few other cool use cases. And then we'll circle back to Spire, and my colleague Max will give you an overview of our newest AIS product, which we're referring to as Dynamic AIS. And then we'll finish it all up with a Q&A. But remember, you can be asking your questions in the question and answer feature as we go throughout the webinar. So feel free to type those in, and then we'll get to as many of the questions as we can during the Q&A. So let's jump in, and I'll talk a little bit about Spire to start. So Spire is a data and analytics company, and we collect RF data from space to solve problems on Earth. So we do that by owning and operating one of the largest Cubesatellite constellations in the world. So we currently have 88 Cubesatellites in operation, and those satellites are supported by 32 ground stations around the world that we also own and operate in-house. And our 88 satellites are in various orbits, which gives us completely global coverage, including over the poles. And so each of our satellites has 3 different payloads on board. So we have the AIS payload, and obviously we'll be talking a lot about that today. We have our radio occultation payload, which we use for weather forecasting. And then we have an ADS-B receiver, which we use for aircraft tracking. And then we can also launch custom hosted payloads. So we have space on our satellite for those. So like I said, today, we're largely focused on AIS, but we may get into a little bit of our weather capabilities as well. So let us know, if there's some interest there too. So this is a map of our global ground network, just to give you an idea really how global we are in terms of receiving our data. And we're kind of continuing to build out this ground network. We're putting in a new ground station or so every quarter. And that will help us, continue to improve our coverage and then also our latency of how we're bringing the data down. And so then in terms of our final data products and how we actually deliver that to the customer, we deliver a highly secure cloud-based data service. So we have fully secured, encrypted TT&C links, data links, and a US-based cloud processing service, through AWS. And our data, stays encrypted from the collection on board the satellite and at the ground station. And it's only decrypted once it is actually in the cloud. And so then we distribute our data through kind of various APIs, as you can see here. And for AIS, that includes our messages API and our vessels API, which Max will get into a little bit more later. And then we also, have a forecast API, which includes our radio occultation data, and that's for our weather forecasting. And so in terms of our product offerings, again, today we're going to be focusing on AIS and what we call our Sense product, which is our maritime domain awareness product, includes our AIS data. But just to quickly run through our other products that we offer. So we also have our Stratos product, which is a weather forecasting product, and it's based on our radio occultation collections and other sources of weather data that we provide. And then our AirSafe product, which is based on that ADS-B data that I mentioned before, so used for aircraft tracking. And then our custom space as a service, or orbital services, as we call it, offering, which includes kind of hosted payloads and other types of bespoke services. So that kind of brief introduction, I'm going to hand things over to my colleague Max, who will give you some additional details on our AIS data and the offerings associated with that.
Cool, thanks, Janie. Yeah, so the first, Spire AIS, Maritime Domain Awareness. So as Janie mentioned, our satellites are tracking AIS signals from ships around the world. AIS is originally used for collision avoidance, but it's a radio signal that all ships in the world are broadcasting, all commercial ships and even non-commercial are broadcasting, giving their position and then some information about their vessel and voyage. We collect that data, decode it, and we put it in two primary APIs. The first is the Messages API, which is a raw decode of AIS messages, but it allows the ability for the customer to filter on things that they're interested in. So if they're interested in only messages from certain ships, they're only interested in certain messages, they're only interested in messages in a specific area, we allow all those filters to be passed into our API, and then they can grab them that way. So it's a lot easier than traditional methods of AIS data collection. Plus, we have 88 satellites flying around the world, collecting way more data than one is usually used to. Our second API is the Vessels API. That creates an object for every known vessel in the world, and it combines the different messages from AIS into making a current picture of the global maritime fleet. So that would be every vessel, when they were last updated, what type of ship they are, whether MMSI, their IMO, these are specific identification numbers for a ship, where they're going, when they plan to be there. Then we add in extra information that is not available but through AIS, and that is also another product we're working on, developing even more predict AI capabilities. Currently, we predict up to 8 hours in the future using a machine learning algorithm that's trained every week on global maritime movements. Soon we'll be able to give an accurate ETA of when each ship will make its voyage from its disembark time. So if a ship is leaving Brazil and going to China, we'll know, we can give you an accurate ETA using a routing engine as soon as it leaves there. Yeah, so if we go to the next slide, you can see the multiple layers we add into or on top of our AIS data. So we have information on geozones, on vessel info, so the ownership, the ship info of the type, the extended dimensions, more than just length and width, but the draft, the air draft, how tall it is, all sorts of different things. Then we can add in our weather data. That is an incredibly powerful feature, with our ability to forecast the weather much more accurately than anyone else. You're able to reduce fuel costs, predict routing, predict global movements, see dangerous areas where vessels may not want to operate in. And then we also have a bunch of other data you can layer on top of that, from maritime events of port closures, congestion around areas, and these are all areas that we're continually developing and adding in at all times with our Sense APIs. All right, next slide, we can show a lot of the data that we're integrating. Yeah, so we have AIS data, we have weather data. These are all from our satellites. We have data on geography, so different areas that you may be interested in. Some people are interested in the global maritime fleet. Other people only want certain smaller regions. We can do it all. And then we partner with other companies to give us specific vessel data, cargo data, events data, imaging, radar data. So a lot of things that go on top of AIS to make that AIS even more valuable. With all that, we have our own proprietary algorithms of AI and machine learning to predict events, predict locations, all sorts of things. And then we put that in through our API or a TCP feed, and that gets to our customers. So it can be extremely customizable what you want to see through our application. I usually say there is no single Spire customer. We cover any type of person who may have a slight interest in the maritime industry, from government customers to commodity traders to logistics companies to ship brokers, etc. So there's a lot of possibilities of what you can do with our very flexible APIs. And then here's just a little bit more about some of our current Predict AI and algorithm offerings. So every ship that we get a position for, we will generate a predicted position for up to 48 hours after the last seen location of that ship. So even though we get, maybe, actually, let me see right now, the average number of messages per ship we get is about 250 positions a day. If we don't have a position from a ship, we will calculate one based on that ship's history and give you that position right now. So every 15 minutes, that data is refreshed. And so you will always know where the ships you are interested in are at any given moment. Then we also have the Predict AI, which predicts positions up to 8 hours in the future. And as I mentioned before, we have a routing engine that will soon be integrated into our API to give positions all along a route for an entire voyage of a ship. And all of that is done in-house, and we just give you the information on where that ship is going to be.
Great, thanks, Max. So now, just to give everyone a quick idea of what kind of federal customers that Spire's been working with on the AIS side. This is a brief list. It's not exhaustive, but a few examples. So we've been providing historical AIS data, including some of our enhanced vessel data, which Max mentioned, to the Naval Postgraduate Schools. They can monitor some vessel trends. We've been working with US Southcom on a combined AIS and SAR product used for detecting dark vessels. And we have a lot of material on that if you have more interest. And then providing, data to the Coast Guard and then FFRDCs like MITRE, and then of course our partner Applied Ocean Sciences, who you'll hear from a bit more later on how they're using our data. And then finally, just something interesting to call out, we did receive some funding from a DoD customer to develop a dashboard that combines our AIS data and our Stratos weather data to help in predicting likely shipping routes, and then taking into account how the impact of certain severe weather events. So it's just some of the projects we're working on with federal customers here at Spire. So now I'm going to pass things over to John from Esri, who's going to give you, an overview on the various ways to kind of visualize AIS data and the kind of cool things that you can do with that. So John, I'm going to pass over to you. Thanks again
for
being on here today.
Thanks, Max. Thanks, Janie. All right, excellent. So I'm briefly going to go over how to use some Spire AIS data in our platform, ArcGIS. And based off of some of the polls, everybody sort of knows who Esri is or familiarity, but if you don't, Esri is the global leader in GIS. Our main goals are to just serve our users to advance geospatial science and just help our customers make a difference in the world. Annual revenue is about over $1 billion, and we're in a lot of different countries with many different partners. And one thing kind of stands out is that we reinvest about 30% into R&D each year. So, and we believe geography is that central item that can make the world a better place. Our users, span the gamut from, national government agencies down to your local administration doing tax parcel information, as well as, nonprofit NGOs, colleges, universities, utilities, different commercial businesses. So anybody who wants to put geography as a central context in making decisions uses our software. So GIS, Geographic Information Systems, it's a framework that allows you to sense and measure and understand information coming in, and as well as to respond to information. So for instance, if I can connect to a Spire AIS vessel and I know, hey, I want to match it up with some other layers, such as, hey, here's some marine mammal areas observing in that area, that's matched those, let's understand there's an issue that's going to be happening, and then let's respond by going into a different area. So putting that into context, that's what GIS does. Our platform is called ArcGIS. It's from web down to just the desktop environment. A lot of traditional users have used ArcGIS Desktop with ArcMap or ArcGIS Pro, but we have a commercial web offering called ArcGIS Online, and that behind the firewall is called ArcGIS Enterprise. And it's powered by different servers and services and content. So you may be familiar with ArcGIS Online or ArcGIS Enterprise or ArcGIS Pro or Desktop as well. So we integrate all types of data. So this presentation is about integrating AIS data from Spire. But you may want to use the ArcGIS Enterprise to integrate other data sets, such as maritime boundaries, weather, let's see, intelligence activity, to understand why vessels are operating as they would. And kind of created this conceptual AIS workflow with ArcGIS. So ArcGIS Enterprise with different apps at the top here, and then it's powered by different servers. So we have different server capability that focus on different items. So ArcGIS GeoEvent server will focus on kind of ingestion and real-time information alerting. The Spatial Big Data Store is a storage mechanism to store lots of data. And the ArcGIS GeoAnalytics server runs analysis on lots of data. So you might use those in parallel to help you understand the AIS coming in. So for instance, say there's a ship out there, transmits location from a satellite or receives from a satellite. The information goes to Spire, and then we ingest Spire's API using ArcGIS GeoEvent server. And we want to run some real-time analytics. So for instance, hey, here's a vessel moving into a restricted area that's getting an alert saying, hey, you're not supposed to be here. You could also visualize the information in ArcGIS Enterprise as feature services or stream services, and that powers different dashboards and web apps. You might want to store the data in what we see a spatiotemporal big data store, and I'll show an example of this later. Allows for quick binning of the data, so you can zoom over to a new area, see where all the ships are at, and then actually get the information of the individual ships. And ArcGIS Geoanalytics server can run analytics off this stored data. So the one here on the left would be, hey, I want to, from all these data, I want to find vessels that are within the same time and space of each other. Or maybe I want to reconstruct tracks of the vessels. So ArcGIS Pro is our desktop offering for GIS analysts. We do have a Spire add-in on the marketplace to allow the consume into their API to grab some of that data. If that data gets to a large amount, we can use a tool called the Geoanalytics Desktop Tools in Pro, which is from ArcGIS Pro 2.4 onwards, which utilizes a Spark framework to process large amounts of data. So typically, a lot of my customers will work in the ArcGIS Pro and try to see if that works with the Geoanalytics desktop tools there. And if they need to scale out, there's always the ArcGIS Geoanalytics server. So there's a Spire AIS data add-in for ArcGIS Pro available on the marketplace. It just integrates right into ArcGIS Pro, so you can bring into AIS data. So I'll briefly go over a demo here in ArcGIS Pro and show the add-in as well as some desktop tools. So here's ArcGIS Pro. I'm kind of centered on more of a CONUS military planning or maritime kind of planning exercise here. So I have a Spire add-in here. I'm going to click on it, and I've already put my API information. So what you would have to do is contact Spire to get an API key, and then you're able to kind of fill out some information. So I can pick out a flag, different ship type here, and then the last update. So if I want to get last 36 hours, you can set that, and then you can just plot the map extent. And what it'll do is just call in those ships that fill those parameters into our map, so we can start using GIS tools in ArcGIS Pro to see if that works here. So now I have some of the ships in here, so you can see, click on the information, understand where they're going. This one's headed to Merchant. This is a tug headed to San Francisco. So hopefully if we click on this guy, we'll get a prediction for it. And we'll take a look here. Let's try this one. So it'll give you a prediction algorithm where it's supposed to be headed. So that's really good, really useful to bring the data. I actually have a lot more data. I have about 1 million records over the past month in this area. It kind of clutters the map as it brings in, but we can understand, hey, there's a traffic lane here that ships are going to. There's a Port Hueneme and Oxnard, and then the ports of St. Pedro, Long Beach, and LA down here. But maybe we want to run some analytics off of it. So as geoprocessing tools, we have a whole bunch that focus on many different types of industries, but a lot of point data like this could be used in the Geoanalytics desktop tools. We've broken them into 5 categories. So analyzing patterns like hotspots and densities, training machine learning models as well. Finding locations like dwell locations is pretty good, where vessels are stopped at a certain time. Managing data is more of your traditional GIS kind of tools, but using the Spark framework. Summarizing, reconstructing of tracks is a lot of maritime users use this. Summary within, and then using proximity, we have a buffer. So what you would run. So for instance, I ran summarize within. So if I want to summarize all the vessels that have gone inside this restricted area here, this is a Channel Islands National Park. You can pick a polygon, speed, and then you can get an understanding about, hey, how many vessels have gone in that area. This is relatively small use case with only about 1 million records and less than that going in, but then you'd have the overall count of vessels in that time frame, and then you can understand what vessels went in those areas. So these vessels, the Freedom, Survey, Contender, sounds like more of survey vessels or military vessels that should be kind of manning those areas anyway. I'd have to do some further research on their MIMSs and their AIS to find out what vessel this is, but gives you an understanding about how many vessels are at scale in different areas. Now, some other tools you could run are calculating densities. I'll turn off some of this. So this can you see the hotspots over time. Let me go change map here, and you can see just some of the areas that obviously the Long Beach and LA and San Diego. Reconstructing tracks, finding out where vessels are going. So you could also sort those on track duration. If I want to say, hey, what's this vessel? Why is it? Let's see where he's at. So this vessel just is a tender and and Coronado. This vessel is just basically moored in one of the ports here. So you get an understanding about where the vessels have been. Next ones are dwell locations. So you can use some of the other tools in ArcGIS, like filtering out based off of features. So what I've done here is actually I've buffered the travel lanes here by, about a nautical mile or so. And then I ran and which vessels are moving slow or haven't moved in a period of time. So for instance, if there's some fog in this area, there's some areas in the travel lanes here that are, or some ships in the travel lanes here that are stopped and basically at anchor. You should be more in these anchorage areas rather than in the shipping travel lanes here. So it gives you an understanding about collision avoidance regulations. And one tool to final is pretty good is the join tool. So I'm going to view this real quick. This takes a little bit longer to run, but it gives you answers like, hey, I want to know what vessels are within 1 kilometer of each other within 1 hour of time. And I'm doing a condition where I want to join them based on their identification number, but I don't want to join itself. So this is, ship meetups, where ships are, transferring, transshipping, or maybe one's assisting the other one. So as you get, I ran it on this entire area, and you can kind of sort the ones away from the ports, but you have the ones that are in ports were totally understandable. But then you have this area, I actually ran this about 6 months ago, and I still got the same area with different vessels here. So this is just an offshore, there's different oil ships and offshore supply ships getting resupplied here as they go into LA and then San Francisco. So these vessels are moving slow at the same time with each other. So using ArcGIS Pro and some of these geoanalytics tools, you can understand it using this big data to try to find some of these answers like collision avoidance or where ships are meeting. All right, transfer over back to the presentation. All right, so we kind of showed more of analysis of like stored data, but if you want to get into real-time analytics, we can use GeoEvent Server to consume the Spire API. If the data is stored, we can use GeoAnalytics Server. And then a new product called Analytics for IoT just came online for ArcGIS at the last Federal User Conference 2 weeks ago. This is actually an ArcGIS Online offering, allowing people to kind of connect to feeds of information and run analytics off of it. It is a like an add-in to ArcGIS Online as well. So now for GeoEvent, those are familiar with GeoEvent. This is kind of an on-prem solution, allowing connecting to feeds. It's broken up into inputs, GeoEvent services, and outputs. So I have one here called Spire Enhanced Vessels, and this is what the GeoEvent service looks like. So you have your Spire in, you're doing some filtering or processing based off of the yellow boxes here. And then you have different outputs. And I have one that's going out to the spatiotemporal big data store, allowing kind of quick rendering of all those positions. And how I did that was I want to pull an external website for JSON. I'm using the Spire API to do that, and I'm doing some filtering based off of what kind of satellite or dynamic or terrestrial and what area I want. So they have great parameters to kind of put in your URL string to define what vessels you want. I put the URL in here. It creates basically a schema with a GeoEvent definition, and then you can basically put your API in key. I kind of blocked out my API. And then you just find what your lat and long is, and then what object, the data object, and how the time is formatted. And then you would have you'd have information in your map right here. So something like this. Here's a web app builder app. This is about last 30 days of Spire. And you can see the higher areas of context of the vessels. If we go into more the South China Sea, the Spratly Islands here, it'll render and show the vessels areas in Singapore, the higher areas. And then once you get down to below, you can see the travel lanes here. And then if we go in, we can click on a vessel, just do a quick search on where it's been, just copy that, and then I set up some queries on the vessels, apply, and then we get an understanding where this vessel has been. So looks like it goes from India to China, and then kind of avoids going dark in the South China Sea area, which could be common. You want to avoid being understood by other entities in that area. So that's sort of his travel patterns. You could also run different tools as too. This is Web App Builder with ArcGIS. And go back real quick to our presentation, and I'll show you analytics for IoT just to finish off the last few minutes. Analytics for IoT, again, it's a hosted app on ArcGIS Online. There's some new feed types that are new item types are part of ArcGIS Online, such as feed, real-time analytics, and big data analytics. So it kind of does all 3. So I actually got a video, hopefully it plays. So here's analytics for IoT. So it's a real-time and big data software as a service capability. It's available right now through ArcGIS Online. It does enable users to easily connect to and make sense of IoT feeds. They're basically connecting to feeds, running real-time analytics, so geofencing and running big data analytics. So I'll show an example here in a moment. Feeds typically connect to external sources of observational data, and such as different IoT platforms, in this case, Spire. I have a few other ones from other business partner, FlightAware here. So in order to create a feed, you just kind of pick what you want. I've already have the Spire data in a feature layer, but what I'm going to do is I'm going to bring this live data source in and kind of store it into a spatiotemporal. So what it does, it kind of picks the schema for you, and it gives you an understanding of what vessels. It basically takes a sample and says, hey, this is what the vessels are. The vessels API is the format. Makes it easier to defining location and start time and end time. And then what we'll do here is define the track ID of the vessel. In this case, it's the MMSI, the identification number of the vessel. And you define how much you want to poll that. So I'm going to say poll it every minute, and then we'll go ahead and save our feed. And then once we save it, it's really easy. You get a view of the data coming in. So no need to configure an output. Say with GeoEvent, the data is already in here. Makes it easy if we're going to switch over to an operations dashboard. We can use that same service on the left-hand side. These are more of the real-time view of the current vessels. And then I have some alerts on some of the real-time analytics. Real-time analytics are good for geofences, transforming of data, and calculating alerts. So if a vessel is slow in the Strait of Hormuz, this scenario is about travel patterns in the Strait of Hormuz, and if there's going to be a shutdown. This is sort of how that operations dashboard was built. On the right-hand side, there's more big data analytics, and they're typically run for summarizing data, trend analysis. And then right here on the bottom, we have a chart that says the average speed over the last few days for hourly increments. So it's pretty indicative of normal traffic patterns. And if there was a closure, you'd see a drastic drop in average speed for the whole fleet going through the area. Some of the other big data analytics, such as vessel journeys, dwell locations, and hotspots can be run. And this map shows a sort of a pattern of life going around the strait here. The red and white dots are vessels that have kind of stopped or dwelling. The red and white pixels are, the white and or yellow and red and blue pixels are Iranian ship hotspots and cold spots. So there's actually an oil platform here. They kind of congregate around there. And then the green and the red are journeys with some gaps in their journeys. So there could be some gaps in AIS. I've seen in a few different providers around vessels when they're going around the point here, just to kind of go dark and to not be seen by people are consuming AIS. And this is sort of how you build it. You have the data coming in, you're filtering out by some expressions or geometries, and then you have outputs here. So calculating the journeys, the dwell locations, the summarization within geofence, and then filtering out based off of different ships. In this case, I'm filtering out Iranian ships, and I'm finding hotspots of where those vessels are. So in conclusion, that's analytics for IoT, and that's how you'd build the feed going in. So any questions, we'll leave those to the end. I'm going to switch over to, or you can also chat them. I'll switch over to back to Janie here. Thank you.
All right, thank you very much, Janie. Let me just get this presentation going. Like you said, Janie, my name's Christopher Linden. I'm the CTO of a little company called Applied Ocean Sciences. We're super excited to be working with Esri and Spire. To give a little bit of background on us, since most of you guys dialing in are probably very aware of what Esri does and Inspire, but we're a new company. We're very small, so I want to talk a little bit about what we do. So we're a company of about 17 people, 12 PhD oceanographers. We do everything from ocean acoustics and radar propagation to physical oceanography, atmospheric science, marine biology, ocean plastics, things of that nature. In the past, our business model has largely been consulting, where we'll solve individual problems for individual customers, and we've experienced a high degree of success doing that. But a limitation that we kept finding was that there's only so many folks you can help if you're having to plug all the numbers in yourself, and if you're having to solve just one solution at a time. So we realized the impact that we could have on our field in oceanography and in ocean conservation would be a lot greater if we could deliver these capabilities to people as a tool. And so we reached out to Esri and have created a very productive partnership where we are starting to port a lot of our analytical tools into Esri software. And a key component of that success has been our ability to consume Spire's global AIS data sets, as well as their weather data sets. So just by way of introduction, what you guys are looking at here on the screen is a global acoustic simulation of the Comprehensive Nuclear Test Ban Treaty Organization's monitoring network. So the red is an area that they can hear very well, and the blue is the areas where they can't hear so well. And what they're doing is they're monitoring for testing of nuclear weapons. And so our company did the acoustic simulations that allowed them to determine where they could and could not detect blasts. Now this acoustic modeling has traditionally been done by teams of professionals with very large computers, but more and more it can be done by users. And so while there are a lot of things that we can do with Spire data in Esri to incorporate it into our greater GIS workflows, I think we've heard about a number of those applications already from our partners at Esri. Everything from monitoring speed restrictions to determining if someone's turning off their AIS for some sort of nefarious purpose, maybe closed area infractions, marine protected area violations, violations of national sovereignty, risk assessments for things like new offshore construction, how it might affect shipping traffic, risk of collision with ships and marine mammals. There's a lot of different things that you can do once you can consume near real-time global ship tracking and weather data, which Spire has made available to everybody through their super easy to use API. So what I want to talk about is a few of the things that we at AOS have done once Spire is able to get their data into Esri, tools that we're able to build in Esri that incorporate those data sets into traditional workflows or workflows that are at least traditional for us. And so just to do a little bit of background, the first application I'm going to talk about is once you get ships and wind and rain and things like that into Esri, and once you're able to consume all those data sets, there's a number of things that you can do in my own field of ocean acoustics that could never be done before. What we're looking at the screen right now is an acoustic simulation. You can see there's a source at the far left, that's where the red is. And the color is red is very loud, and light blue is less loud, and dark blue is very quiet. And so the key takeaway from this plot is that the way that sound propagates in the ocean is complicated, and it depends on things like temperature, salinity, even pH of the water, as well as the bathymetry and the bottom composition. And you need to know all of those things in order to do good quality acoustic simulations. And you might think, so what? Why do I want to do good quality acoustic simulations? And like I said, this is just one application of the many that you can do with the Spire data. So this figure right here, if you look at the far left, you see a figure labeled 20 log R. That is sort of the industry standard. If, for example, you were to put in for permitting to do some sort of offshore construction with the Bureau of Ocean Energy Management, you would be required to estimate what your impact of your construction would be on local marine mammals. And the traditional way this is done right now is by a very simple range formulation of 20 times log base 10, the absolute value of the range. And that's where you get that exponentially decreasing red blob there on the far left. And you can see that it's the same through land. It doesn't account for any of the oceanographic parameters, and so it's insufficient in order to give you a good idea of where the sound's actually going to go in the water, and as a result, the impact that's going to have on marine mammals. If you look at the far right, that would be sort of the high-end industry standard. That would be what most Navy simulations do, which is they run between 16 and 32 radial ray trace simulations and interpolate in between. And that's okay. You can see that it has some pattern there, but it still does not capture the complexity of the of the geography of that area. So the simulation in the center is a full 3-dimensional parabolic equation acoustic model, and that's what we run at Applied Ocean Sciences. And so the thing that we're very proud of is we've managed to make our models very, very good and very, very efficient, which allows us to do things that we haven't been able to do before. For example, run global simulations like this in a matter of seconds. So this is that same figure that was on the rotating globe in the first slide, but in the Spillhouse projection, which is a great projection that Esri just added to their portfolio of projected coordinate systems for describing global ocean data sets. And so this is, in Esri, the global coverage of the CTBTO hydroacoustic monitoring stations. And so doing global simulations is now possible. And what we've done is we've created tools within Esri in order to conduct those simulations. So you can load your ocean in your bathymetry, and then you can run a global acoustic simulation or an acoustic simulation of what a ship sounds like and how loud it's going to be where. And what that then allowed us to do when we teamed up with Spire, which is super exciting, is model every ship everywhere in the world all the time. Add in the noise contributions from wind, which underwater, most of the noise comes from either wind, ships, a little bit of rain, and some other stuff like sea ice and seismic stuff. But we're able to model the ambient noise everywhere in the ocean all the time in near real time because Spire has made their data available through their super easy to use API. We consume that API, we model all of those sources, all those ships and all of that wind noise, and then can also port it straight into Esri as a map service. And so now you can, in real time, model the noise everywhere in the world. The next very cool thing that we can do, only with Spire, is they've done ship forecasting. So they even forecast forward based on the course and speed and destinations of vessels where they're going to be in the future. And so you can even forecast what the ambient noise is going to be in the future, again, entirely with Esri geoprocessing tools. So let's talk about why that might be useful. So first of all, this is a month animation of Spire's global wind data converted into what the effect is on ambient noise. You can actually see a hurricane moving up the east coast of the United States there. And hurricanes are very loud, which shouldn't surprise anybody. But if you were trying to determine if you could detect a whale or something and that hurricane moves over, obviously you can see that, well, you probably won't be able to detect it because the ambient noise because of that hurricane is so loud. We then took every single ship in the world, and this is just sort of a zoomed in simulation of a single vessel entering the Strait of Juan de Fuca here in Puget Sound, Washington, and simulated every single ship in the world. And so at any given time underway in open water, there could be up to 400,000 ships. And so what we're very proud of is that our models are efficient to the point where we can actually run, all 400,000 ships all the time using Spire's API. And that looks something like this. The animation's a little choppy. I think that's just the rendering in PowerPoint here, but you can see the ships as they move across the water. And so this is a global simulation of every single ship and wind noise directly consumed from Spire's API, ported into Esri. And this is just what a single snapshot of that looks like, again, in Esri's great Spillhouse projection. So what, right? Why does it matter that we can know what the ambient noise is everywhere in the world? Well, whales care a lot about that sort of thing. Whereas you and I interact with our environment with our eyes, whales interact with their environment acoustically. It's how they know where they are, it's how they find each other, it's how they find food. And so acoustics impacts every aspect of their life. So if you've ever wondered what entering Puget Sound, Washington looks like to a whale, you can see these are the Spire ships moving, the real-time ship simulation, and to a whale, all they can see is, well, I guess what they can hear. And so where it is loud and where it is quiet, basically where there is ship noise and where there isn't matters a lot to their ability to navigate and interact with their environment. So if you're a marine biologist, conservationist, these sorts of tools now made available through Esri's ArcGIS Pro platform become very valuable. This is an application of it to a very specific problem where we had an acoustic monitoring station off of Martha's Vineyard, and we wanted to determine where we could hear right whales, because this monitoring station was designed to monitor a Navy and Coast Guard gunnery exercise area, and they wanted to make sure that they weren't doing target practice while right whales are in the area, which is obviously a good thing for everybody. And so this shows sort of a 3D animation of what that acoustic simulation looked like. But now with our tools, what we're able to do is take that 3D simulation and run it through Esri as a geoprocessing tool. Take sort of a horizontal slices through that if you care about what your detectability is of an animal at a certain depth. And you can see just what that looks like from a top-down plan view, and then port it into Esri. Then we can just threshold it, then we add in Spire's ambient noise, and that will tell you where you can hear what sort of animal when. So this is what that looks like in Esri. And then if you threshold it by various noise levels, you can determine exactly where you can detect the animals. And so this just shows the wind noise, the ship noise, wind and ship noise summed together. And then these are the detectability areas of a right whale and a humpback whale. And on the top you have right whales, and on the bottom you have humpback whales. On the left you have noisy days, basically where it was very loud because of weather. And then on the right you have quiet days. And what you can see is in our area of interest, on the noisy days where there was either a lot of vessel traffic or lots of wind, we really couldn't detect the animals anywhere. Whereas on a quiet day, the figures on the right, a calm day or with very little ship traffic, we could detect the animals anywhere in the area we were interested in. And so what that tells you is how important it is to understand that ambient noise for all of your detectability questions. And then of course in Esri you can make very cool looking pictures of the same thing. This is that, but classified by what weather or the detectable area based on weather. So the Beaufort scale, 0 being totally calm, 12 being a hurricane. What this tells you is the purple area. You can detect a vessel, on a very loud day in a very small area, and you could detect, not a vessel, a whale in a much larger area, the yellow, on a quiet or calmer day. And that's about it. This is some work we're doing in Colombia where we're able to model every ship using Spire's feed. And you can see the area up in the inland waters in the Gulf of Tortuga there, if you know the geography in the area. The reverberation in the shallow water makes it a much noisier environment. And so I think that gives you the general idea of what you can do from an acoustic standpoint. We of course have modeled it for defense applications as well, optimizing sensor placements, and can create dashboards in Esri to do that for you. This, for example, is again in the results of an Esri optimizer for determining how many sensors and where you should put them in order to monitor the entire border between US and Mexican exclusive economic zones. And so it would take 38 sensors in those locations in order to do that. And that's a tool, again, you can now access through Esri. This is a different application for lightering. Lightering is where 2 vessels transfer cargo offshore. It's a concern because if they're doing it in international waters, it sometimes doesn't require permitting, and spilling things like petroleum products is a concern, and it's difficult to track them. But it's pretty intuitive that if you have Spire's AIS feed and a couple of vessels carrying the same type of cargo pull alongside each other for a few hours, you can just flag those vessels, and it's very simple to write the tools in Esri just using Python or your model builder, or you can hire professionals like us if you wanted to build these types of tools for you. But the point is you can then identify all these vessels engaged in lightering. So this is a heat map of all the places where 2 vessels carrying the same cargo going less than 2 knots stayed right next to each other for greater than 6 hours in a month-long period. And it correlates well with known and reported cases of lightering. IUU fishing, same thing. And so I think that's about all the time I have. So I'll turn it back over to you, Janie, and if there are any questions, I'd be happy to answer them either now or offline.
Great, thanks, Chris. So for our last piece here, we are going to have Max talk a little bit about Dynamic AIS, which is Spire's kind of newest flavor of AIS data. And I think we've had a few people asking and interested about it, so definitely want to provide more information on that. And we're pretty excited about this offering as it really increases our ability to track vessels in high traffic zones in particular. So I'm going to pass things over to Max to provide you a bit more info.
So AIS is broadcast over a very limited spectrum of VHF, very high frequency radio. And so when there's a lot of vessels in the same area, those messages can become what's called collided, and it's difficult to interpret which vessel is broadcasting which message. In areas like the Persian Gulf, where there's a lot of activity, this is kind of mitigated because there are a bunch of terrestrial receivers taking in that data all at once. You might have several thousand terrestrial receivers over, a several kilometer square kilometer area. For satellite, that can become difficult because one satellite, as a plus, covers 2,400 kilometers of radius around where the satellite is orbiting, projected onto the Earth. But then there's areas like the South China Sea, the Gulf of Mexico, and the North Sea that are very high trafficked, but not close to land. So while there's high traffic there and we do get messages there, they're not proportional to the amount of ships that are operating there. And that's just raw AIS collection. So every AIS provider has difficulty covering these high traffic zones. And there are obviously very high value areas as well. So with that, we have solved this problem with Dynamic AIS. Want to go to the next slide? Yeah, perfect. So what we did is we put AIS receivers on ships moving through high traffic zones, 1,500 of them, going to 2,000 soon. And those AIS receivers collect all the AIS messages along their high traffic zones and then broadcast them individually on a different spectrum to satellites that can then bring them back down to Earth and be made available in our API. This makes a volume of 7 million dynamic AIS messages a day, roughly 55,000 MMSIs a day, and 10,000 MMSIs per day that were not seen by any other AIS provider. So what that's basically giving you is each day you're able to see 10,000 more vessels that were not seen by anyone else. So in the ocean, I kind of went over this on the previous slide. In the ocean, it's great that a satellite covers a 2,400 kilometer radius of range, but when you go over a high traffic zone, you really need that more high fidelity, lower range, higher fidelity. And we've done that by just covering vessels in high traffic zones with receivers that then broadcast over a different spectrum to be collected and then made available in our API. So over a 24-hour, setting a new standard in tracking. So we deliver 56% more messages and 25% more unique MMSIs in the South China Sea alone. So that's a very common area. You can see the specific South China Sea is at the bottom of this picture, and you can, from Singapore to past Vietnam, all the way up to Taiwan, there's that whole area that's extremely high traffic from ships going from the Persian Gulf to Asia or Asia to Europe, Africa, etc. And that's not near land. So we have a whole bunch of ships in these narrow shipping lanes that we're now capturing all these messages from Dynamic AIS enabled vessels. This increases the fidelity in that area extremely high and allows anyone interested in these specific high traffic zones a unique solution that's not offered by anyone else to be able to track vessels more precisely in these areas. And I should point out too that in this graph, the red is messages collected from dynamic, the white is messages collected from terrestrial receivers, and the blue is satellite. So you can see to the right, in the Philippine Sea where there's a little bit less traffic, satellite is still very, very good at capturing more spread out vessels, and you can see the little clusters of where fishing operations are happening. And then the red is showing this dynamic capability that's capturing all these commercial vessels as they go through major shipping lanes from China and Japan all the way over to India. Yeah, I think we're gonna do one more poll right after this, but then I'm happy to answer any more technical questions about dynamic AIS capture and what Spire provides.
Awesome. Thanks for that, Max. And definitely, like you said, we have a lot more information on dynamic, and we're pretty excited about this. So please reach out and let us know if you want more information on that in particular.